And the important part is it's not 6. It's 6-ish. 6 and a bit of an extra. So this is the big question. I want to know I want to know exactly how many of these S lengths get us all the way around. All right. I want to know exactly. I don't want any decimal crap. I need to know exactly. Okay? So let's look at these S lengths here. The S length is all the way around the circle. And we want to go all the way around. All the way around is a measure of... No, how long is it? What is its length? Circumference. Very good. So we want to know how many of these S lengths equal the circumference of the circle. Well, how do you find circumference? 2 pi r. Yes. Okay. So now, again, how many S's equal the circumference? Well, S is the same as the radius. So I'm going to take that R and replace it with an S. So again, I'm trying to find how many S's equal the 2 pi S. How do you get the question mark by itself? Divide by S. So 2 pi radians make one full wrap around the circle. Ladies and gentlemen, what is pi? 3.14. And what is 2 times 3.14? About 6.28 radians. 6-ish. 6.28-ish radians get us all the way around the circle. I will never use 6.28, but you have to understand that pi is a number. And so if I said to you, draw an angle measuring 4 radians, what would you draw?
4 lines.
What quadrant does the terminal side land in?
I got 60. Bottom right. The fourth. It lands on the initial side.
Starts here.
The initial.
Oh, wait.
What quadrant?
Oh, the third quadrant.
Third quadrant. 1 radian, 2 radians, 3 radians, 4 radians. This is a 4 radian angle that lands in quadrant 3. Okay? Though that's the test question right there. Is a radian equal to a degree? No. Okay? 1 radian is not equal to 1 degree. Naomi. So radian is the length of the radius. Okay? So that's why it's radian. It's like the radius. And that radius we just wrapped around. It does cancel out. Yeah. Yeah. So it turns out that a radian is actually unitless. It does not have any units attached to it. Because it cancels out, exactly what you said. The units actually cancel out. When we use radians, we adopt any unit that we have in our problem already. So those units will come later on. So it turns out to get all the way around our circle, 1 full revolution is equal to 2 pi radians. So 1 full revolution is equal to 2 pi radians.
Is the pipe cleaner thing like the only way to measure this? So like we'll have to do.
So it turns out, so the question was, is the pipe cleaner method the only way to find a radian? So we can always approximate it. So for instance, if I'm using my arm as angles, and here's my positive x-axis, and I'm opening up, I can imagine I'm opening up about the length of my arm, wrapping it around. So that'd be 1 radian, 2 radians. Okay, and it turns out that radians are cool because it doesn't matter how big or small your circle is. It's dependent upon the size of the circle. The bigger the circle, the bigger the arc that it intercepts. Okay, so
They're always going to be 6
6-ish. Yeah, so that's what this means. 1 revolution all the way around is 2 pi radians. Exactly. No ish about it. It's exact. Okay, so we know that so radians are a measure of rotation, just like degrees are. 1 revolution is how many degrees? 360 degrees turns out to equal 2 pi radians. Well, I can simplify that a little bit. Can I reduce that? Divide by 2. So pi is equal to 180 degrees. And this is our unit conversion that we'll be using. You'll notice that I am very careful about writing the degree mark. The degree symbol is really, really important. 180 degrees is equal to pi radians. And this is really important for us because in this class, we will almost never use degrees. We will use them today. All right? But most of the time, we're going to be working with radians. So you need to understand radians really well. And so to do that, this knowledge is very, very helpful. So I want you to trace a circle again.
What kind of food was this?
It's a jam.
And I bought them. And again, I need you to draw that x-axis in there and find about where that center is. Bless you. Okay, so we need to practice drawing angle measures in radians. And so I want to start by drawing an angle. It's got its vertex at the center of my circle and initial side along the positive x-axis, okay? This angle is 0 radians, all right? It's also 0 degrees, but 0 radians. So what I want to do is I want us to draw angle theta that is 3 pi over 2 radians. You do not have to write radians. I will only write them today, okay? As a reminder that we're talking about radians. 3 pi over 2, kind of weird. Well, we're going to start right here with the pi. Where's pi? 180. Watch my hands very carefully. I'm going to do this every day. Where's pi? 180. Do you see the straight angle line forming with my hands?
Yes.
Okay. So this is the visual record. Where's pi? 180. We know over right here, we know that it's 180 degrees. It's equal to pi radians. So I put a little dot there. I'm also going to put a little dot right at 0 where we begin. Now, pi radians is halfway around our circle. What this is telling me to do is do pi divided by 2. What does that mean, pi divided by 2? 9. It's take the pi and cut it into 2 equal pieces. So look, I can put a dot right in the middle. Now I have 1, 2 equal parts. Okay? That's pi divided by 2. pi divided into 2 equal parts. Now, whatever you do on top, you also have to do on the bottom. So we're going to, again, split that bottom half. Okay. What we have done is taken pi and divided it up. Here we have 2 equal parts. Now, we want 3 pi's over 2. It's just counting. This would be 1 pi over 2. Sorry, that says 1 pi over 2. Right here is 2 pi's over 2. I'm sorry. Hunter. Do I have it? Yeah. Oh, sorry.
Bye, Hunter.
I'm deep in the Radian mode right now. Okay. 1 pi over 2, 2 pi's over 2. What's down here? 3 pi's over 2. Whoa. What's this? 4 pi's over 2, which is 2 pi all the way around. What happens to 2 pi over 2? It's just pi, isn't it? It all reduces. All right, so I want to draw the angle 3 pi over 2. Here's my initial side, 1 pi over 2, 2 pi over 2, 3 pi over 2. So it goes through. Right here is our angle 3 pi over 2. Also known as 270 degrees. Okay? Okay, so now I want to draw one more angle, so we do this again. I want another angle. This one we're going to draw is 7 pi over 4. So we want to draw this angle, 7 pi over 4. So we start with, where's pi? 180. So right over here we have our pi. And what do we want to cut pi into? 4 equal parts. So I'm going to take this top half. I've already divided it into 2 equal parts. And what do I need to do to make it 4? Divide those. So that I have 1, 2, 3, 4 equal wedges. Whatever I do to the top, we want to do to the bottom as well. How many wedges gets us all the way around the pie? 8 wedges gets us all the way around the pie. All right. This is my size piece of pie. That's right. The 8 wedges of pie. Okay. All right. So this first dot represents pi 1, pi divided into 4 equal wedges. 1 pi over 4. What's this one? 2 pi over 4. What's this one? 3 pi over 4. What's this one? 4 pi over 4. Here. 5 pi over 4. What's this one? 6 pi's over 4. What's this one? 7 pi over 4. That is my 7 pi over 4 angle right there. Okay. 7 pi's over 4. Woo. So there is our big 7 pi over 4 angle. Okay. Is it what? Do you what?
Like the angle size.
Angles? Yeah. Okay. So we're going to do some more practice with this. So again, and what's cool about these things, if you wrote 8 pi over 4, what does it reduce to? 2 pi.
That's crazy.
Yeah, just like 4 pi over 4 reduces to 1 pi. Okay, everything reduces. It's magical. Okay. All right. Sample 1. Yes, example 1.
Oh, no.
No.
Guys, don't play, let's go. Bro, I thought these were examples.
Alright, because this is a long lesson, I am going to sort of consolidate these two examples into one. Draw the angle in standard position, find the complement and supplement of each angle, and one positive coterminal angle and one negative coterminal angle. All right, so we have a bunch of things to figure out here. And again, I'm going to start the angle theta that they're giving me is 3 pi over 8. So I'm going to go ahead and start again. It is, I think, really helpful to have a picture. You can do the math, but the math is really awful. Yeah, you're going to be drawing circles all over the place. Okay. So I want to start by drawing our angle 3 pi over 8 in standard position, which means that the initial side is running along our positive x-axis. This is 0 radians. And so I'm going to start with pi. Ladies and gentlemen, where's pi?
180.
Okay, 180. Right over here. Make a dot. That is pi radians. What are we cutting pi into? 8 wedges.
16.
So first I'm going to split it in half. And, I got to get 8. I'm going to split them in half again. Now how many wedges do we have?
4.
4. What do we need to do to get 8? Split those in half. Oh, boy.
72.
Okay.
72 wedges.
So you can see that there's 1, 2, 3, 4, 5, 6, 7, 8 wedges. All right, now, whatever we do to the top, we need to do to the bottom as well. So we're going to duplicate, reflect it over. So split it in half. Half again gets us fourths. Oh, I missed. That's not half. Yeah, that's better. Okay. And then, so ladies and gentlemen, how many wedges gets us all the way around this circle? How many pieces does this pie have?
8 times 2.
8 times 2 is 16. Okay. All right. How many of those wedges do we want? 3. We want 3 pies over 8. This first one is 1 pi over 8. What's the second one?
2.
2 pies over 8. And this third is 3 pies over 8. So right there is our angle. 3 pi over 8. Right there. Okay? Okay. Ladies and gentlemen, the first thing we want to know is what's the complement? What does complement mean?
1 pi over 8.
What? It's a 90. So 90 is 90 degrees, but we don't have 90 degrees. Yeah, what one gets us to 4 pi over 8? 4 pi over 8 is that straight up 90 degrees. One, yeah, this little bit right here, that is just 1 pi over 8. Okay? To complete that wedge, that full 90 degree wedge, it's just 1 little pi over 8. You see that? What's the supplement? What's the supplement?
No. It's literally 5 pi, Sam. Oh, 5 pi over 8.
How big is each wedge, ladies and gentlemen? Pi over 8. Pi over 8. This
1, 2, 3, 4, 5.
1 pi over 8, 2 pi's over 8, 3 pi's over 8, 4 pi's over 8, 5 pi's over 8. All right. Does that make sense to you? I know it's weird, right? Here is where my 3 pi over 8 ended, right? The supplement is the angle that gets me to the straight angle, right? Yeah, each little wedge is pi divided by 8. It's pi over 8 size. So this is pi over 8 and pi over 8 and pi over 8 and pi over 8 and pi over 8. 5 pi's over 8. Okay. All right. Those are the easy things. Okay. Let us find the negative coterminal angle. Negative coterminal angle. Coterminal means what?
The terminal angles touch.
The terminal sides, they land together. They also start at the same place. We want a negative angle. Starts along the positive x-axis and goes in the negative direction and lands right here. How big is that?
Negative 5. It's negative plus 5.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Negative 13 pi's over 8.
19 pi over 8. This 19 pi over 8 is positive. Because you take 16 pi over 8, which is 360.
All right, last one real fast. What's up? We're going to finish this tomorrow, but positive coterminal
19
angle.
pi over 8.
How'd you get 19 pi over 8?
Because you take 16 and add 3.
All right, listen up. Here we go. If I go 3 pi over 8, I land at that same terminal spot, the angle, the original angle. But I want to keep on going around. 1, 2, 3 pi's over 8. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Did I miscount? 16, 17, 18, 19. It was positive, but I need a different angle. So I can't use the one they gave me. That doesn't count. That's cheating. I need to go one full rotation. All right, we're going to finish this up. Ladies and gentlemen, pick up the worksheet. You can do the front side. Pick up the worksheet. You can do the front. It does.
Well, I'm grabbing one for my friend.
Pick up the worksheet. You can do the front.